Alright, let's talk about, there's a bicycle example. If you want to look, we're on page 325 in the book. But, if we want to build a bicycle, you've got to have a frame. And I'm going to attempt to draw this. Let's see how well I can do. So here's my frame and the seat. Okay, that's the frame. That's not too bad. Plus, I need two wheels. Got two wheels. So I've got my frame, F, plus 2W wheels. And I've got some handlebars. That's close enough for handlebars. Plus handlebars and some pedals. So I've got two pedals. So I don't know, something like that. Plus two pedals. And that yields a bicycle. So somehow we're going to draw this thing. Okay, we're getting all these things in here somehow. Alright, there's my handlebars, and here's my pedals. Yeah, something like that. So, here's kind of what we've got. This is our equation. What we're trying to do here is talk about balancing this equation. And, my final product here is F. I need two wheels. I need high handlebars, and I need two pedals. So, notice that I start with a frame, two wheels, one pair of handlebars, two pedals. I put it all together in a compound, and notice that I've written little subscripts on this side when I'm talking about a compound. Over here, I've written big numbers out front. Those are known as coefficients. And these are, and what we're trying to do is make sure that whatever we have on the left, we have on the right. And so you can see that I've got two W's there, and I've got two W's there. It's just written slightly differently. Got one F, I've got one H, and I've got two P's on both sides. So I have a balanced equation for my bike. Okay, so just a few things. We've talked about some of this. Coefficients, those are the whole numbers that we put out front. So when we're talking about, like, if we say oxygen gas, and I say we need two of those, that's this number out front is a coefficient. We can add those to make things balance. They always have to be whole numbers. A chemical reaction is described by balancing this equation. In other words, what we're saying is however many atoms I start with, I have to have when I'm done. It's the law of conservation of matter. It says you can't create something or destroy it. So whatever I have when I start, I got to have. If I started with 10 atoms, I got to end with 10 atoms. And I got to end with the same 10 atoms that I started with. Okay. So the first thing we're going to do, first thing we would do is write a skeleton equation. So you figure out, well, what are the things that are going to be there, and write that skeleton equation. Then you've got to balance it in such a way that that equation, is completely balanced. For instance, we've done this. We said, well, let's take some sodium and some chlorine, and let's get sodium chloride. Now here's the key thing that a lot of people make a mistake on is they say, hey, well, I just want to come over here and write a little 2 down there. I want to put a 2 there, and that'll make everything balanced, except that this is not the way sodium chloride exists. So you can't do that. We do know sodium chloride is NaCl. I mean, Na is +1 and chlorine is -1. Therefore, it has to be NaCl, cannot be NaCl2. Don't try to change it. So first, write the skeleton. Get all those things down correctly. Then, go back and balance it. Now, what we can do, once we've done this, is we can change these coefficients out front. So notice here I've got 2 chlorines, but here I only have 1. So I need to double that. I need to take it times 2. And I'm going to put it out front. I have to put it out front of the compound. I can't put it in the middle. A lot of times people try to sneak it in there. You can't do that. You can't break it up. That would be, you put if you want to have a 2, you put that little 2 down in there. But once again, like I said, that's illegal. You can't do that for NaCl. It just doesn't exist that way. So we have to put that 2 out front. Now what that did then was mean I've got 2 NAs and 2 Cls. So it kind of messed up my NAs now. Now I've got to go back and balance that out. So on this side I now have 2 NAs right there. Got 2. I need to get 2 over here. So my final equation, 2Na plus Cl2 yields yields 2 NaCl2. So there's 2 sodiums, 2 sodiums. I've got 2 chlorines, 2 chlorines. Okay, so it's balanced. It obeys the law of conservation of mass. All right, let's take a look at this problem. We've got hydrogen. We've got some oxygen, and it forms water, and we want to balance that. And notice that if I look at H's, there's 2 on the left, there's 2 on the right, so that's good. So we then go on to oxygen, it's 2 on the left, 1 on the right. Notice that they're H2s and O2s. That's because they are diatomic. So we learned diatomic earlier, and now we really have to apply that, because whenever we talk about oxygen gas, hydrogen gas, something like that, excuse me, we have to worry about diatomic molecules. So I'm going to need more oxygen on the right, and the only way I can do that is to put a 2 in front. But then, of course, that messes up the hydrogen, because now I've got 2 times 2, or 4 hydrogens. So I've got to go back over here and fix that and put 2 over there. And now I've got a balanced equation. So my final balanced equation is 2H2 plus O2 yields 2H2O. Remember, the number out front, this is like algebra. The number out front, it's distributed over the whole thing. So this 2 times this 2 says, hey, I've got 4 hydrogens. There's no number in front, so I've got 2 oxygens. Over here, I've got 2 times 2. That's 4. Remember, it's distributive. 2 times 2 here, or 2 times 1 there, is 2 oxygens. So I got the same thing on both sides. That's exactly what I'm trying to do. All right, stop the video. Balance. Do questions 3 and 4. Okay, so let's work through this first one, and you've got AgNO3 plus H2S yields Ag2S plus HNO3. Now, notice this. This is something to keep in mind. Here's NO3, and if you recall, that is a polyatomic ion nitrate, and there's NO3, polyatomic ion nitrate. It is easier to keep those things together than it is to try to count it as nitrogen and 3 oxygens. You think of it as 1 nitrate, because typically in most things they tend to alright, so you can see we've got this new problem. Aluminum, oops, give me my pencil. Aluminum plus oxygen, O2 yields Al2O3. If I try to balance this, let's say I start with trying to balance the aluminum, I put a 2 there. That's all good, but now I've got problems with oxygen, so I'm going to have to put a 2 there and a 3. Oh, sorry, the other way around. Let's erase that. It's going to have to be a 3 and a 2, and you'll notice that when you do that, that messes up your aluminums, and it's easy to sometimes, keep going, and you may end up with something like that. And notice that you could take a 2 out of every term there. So anytime that you can do that, you need to reduce down. And we're always looking for the lowest ratio that we can get. So this is the right answer right there. Okay, why don't you guys try 5 and 6. Stop the video and work on those, and then turn it back on when you're done. Alright, so 5, Fe Cl3 plus NaOH yields FeOH3 plus NaCl. And if I look at that, and let's start with iron's okay, so let's start with chlorines. We've got 3 on the left, 1 on the right, so I'm going to need 3 over here. And that's good. And then that messes up sodium, so I'm going to put 3 there. And I've got 3 OHs, and I've got 3 OHs, so that's good. So that looks like we're done on that one. Okay, for B, CS2 plus Cl2 yields CCl4 plus S2Cl2. And if we look at this, okay, we start with, oh, we got chlorines, we got chlorines, we got chlorines. Whenever you see that where it's in like multiple ones, I like to wait with that one till the end because they tend to be the hardest ones to balance. So check the other ones out first, okay? And so if we look at this copper or carbon and carbon 1, so that's good. Sulfur 2, so that's good. So the only thing we do have to balance are the chlorines. And we've got 6 chlorines on the right. And we've got 2 on the left. And what times 2 gives me 6? Well, 3 does. So that's my answer there. Alright, if we do the last one, calcium hydroxide, that's Ca parentheses OH2 plus sulfuric acid, that's H2SO4. Let me get some of this out of the way. Yields calcium sulfate, CaSO4, plus water, H2O. So if we take a look, calciums, they look good. Okay, sulfates, they're good. So we've got 2 hydroxides and 2 hydrogens. Remember, I told you that we can think of water as being HOH, hydrogen and hydroxide. So if I've got 2 hydroxides and 2 hydrogens, that's going to make 2 waters. So I would have a 2 right there. And that would be it for section 1, balancing chemical equations. How fun.